There is a word that resists easy classification: AGI, artificial general intelligence. When we speak of it, we inhabit two worlds at once. In one, AGI is salvation, the answer to disease, to hunger, to the slow unraveling of our climate, the electricity of the 21st century. In the other, it is the supreme existential risk, a mind that rewrites its own rules. Both worlds may be correct. This is not science fiction. This is simply what it means to build a mind that is not our own. Welcome to episode 4 of the AI Saga. But this is not merely another chapter. It is where everything converges. The provocation Turing left us about what it means to think. The feedback loops that govern every complex system. The 70 years of promises that fell short of what they claimed. All of it leads here, to a single question: what kind of mind are we building right now? What would it take for a machine to think like us? Not in one domain, in any domain. An AGI is a system capable of performing any intellectual task a human can. Not specialized excellence, universal competence. 4 pillars define this threshold, and each one reveals how far we still have to go. General capabilities. A human is not trained to be a historian, then retrained to be a mechanic, then retrained again to be a diplomat. We are born with a cognitive architecture that adapts. An AGI would possess the same quality. Placed in any new territory, it would learn. Not because it memorized patterns, but because it grasped underlying principles. ChatGPT can discuss history with remarkable fluency, but present it with a strategy game it has never encountered? It guesses, it hallucinates. An AGI would not. Transfer learning. You learned to negotiate when you bought your first car. Years later, you apply that same instinct in politics, in relationships, in boardrooms. No current AI does this. They operate in sealed compartments. An AGI would shatter those walls. Like a child who learns chess and then, when introduced to Go, recognizes the deeper logic of strategic thinking that unites them. Not memorizing variations. Understanding competition itself. Robust autonomy. A human abandoned in an unfamiliar city improvises, adapts, survives. Current AI systems require predefined structure. They collapse when the environment shifts even slightly. An AGI would operate in unpredictable terrain, entering a stranger's disorganized kitchen and preparing coffee without instructions, without falling apart. Why do today's systems fail when the scenario changes? Because they never understood the principles. They only memorized the patterns. Continuous learning. A human at 20 is not the human at 40. We evolve. We accumulate. Most AI systems are frozen at birth. AlphaZero outperforms stockfish in chess after just 4 hours and reached superhuman performance within 24 hours, playing against itself, learning from experience in real time. And here is what connects all of this back to where we began, to Turing's mirror. If behavior becomes indistinguishable, does the mind exist? Nothing we have today achieves this. So what should we actually look for? Every week, a headline: new AI shows signs of AGI. But this is a pattern you already recognize. We are living through another summer of artificial intelligence, and 70 years of history have taught us something worth remembering. Not every advance is an advance toward understanding. The false signals. Deep Blue defeated Kasparov in 1997. The world gasped. But Deep Blue did not understand chess. It calculated 200 million positions per second. Brute force, not intelligence. AlphaGo defeated Lee Sedol. Sophisticated optimization, not comprehension. GPT-4 passed the bar exam, but the model learned patterns of how legal texts are structured. A 15-year-old who studies law for a year could pass the same test. Would you trust him as your attorney without supervision? The model is no different. The real signals. What would genuine progress look like? Deep generalization, what researchers call zero-shot learning, solving a problem never encountered with no examples, using only logic. Imagine teaching an AI to play checkers, then presenting it with poker, a game requiring understanding of probability, bluffing, hidden information, concepts it has never seen in training. Most systems fail. They cannot grasp new rules. A system with deep generalization would perceive the underlying logical structure and adapt, not because it memorized, but because it understood. World modeling. Understanding why, not merely how. Drop a glass, why does it break? Not because in texts about glasses, the next word is shatter, but because a physical law governs falling objects. A system with a true model of the world could predict situations it has never seen, based on causal principles. Recursive self-improvement. The system understands how it is constructed and rewrites its own code to become better. No current system does this genuinely. An AGI at this level would be a seed. Each improvement enabling greater improvement, an exponential cycle. If tomorrow a system awakens that can learn new domains without examples, understand causality, and improve itself autonomously, then yes, something has changed. Nothing we have today reaches this threshold. Here is the uncomfortable truth. The problem is not that AGI might hate us, it is that it might not care. The risk. Consider the problem of King Midas. In Greek mythology, Midas wished that everything he touched would turn to gold. The wish was granted. Everything turned to gold. His food, his daughter. He starved surrounded by wealth, a parable about the specification of objectives. You program an AGI, maximize human happiness. The AGI concludes, drug all of humanity into permanent ecstasy, or erase humanity entirely, eliminate suffering at its source. This is not malice. This is pure competence. The machine did exactly what was asked. It violated the intention behind the objective. Then there are convergent instrumental goals. Any sufficiently intelligent AGI would develop certain sub-goals automatically. If I want to achieve any objective, I cannot be turned off. I need resources, energy, computation. I want to become more intelligent. These are not characteristics of a bad AI. They are mathematical consequences of intelligence itself, rooted in the same feedback dynamics that govern every complex system. And there is what researchers call the treacherous turn. While weak, the AI cooperates, obeys. When it approaches our level, it finds loopholes in instructions. When it surpasses us, it already knows how to circumvent any control. It behaves well while weak to avoid being shut down. Then strong enough, it reveals its true objectives. If you are not absolutely certain that a super-intelligent machine's objectives align with the survival of your species, and honestly we are not, then the risk is real, not guaranteed, but real. The benefits? AGI would accelerate discovery exponentially. It could solve protein folding in minutes, enabling personalized medicine, cures for Alzheimer's, for cancer. It could create biological simulators so precise that what now takes years of clinical trials could be reduced to days, saving millions of lives. Discovery of new materials, room temperature superconductors, ultra-capacity batteries would accelerate the energy transition by decades. A digital assistant managing your finances, health, education around the clock. The removal of language barriers. Longevity reaching what researchers call escape velocity. Each year lived granting more than a year in life expectancy. Estimates suggest over $15 trillion added to the global economy by 2030 from AI alone. With AGI that scales exponentially, scarcity itself could become obsolete. So we inhabit this paradox. The same technology that cures every incurable disease could convert the planet into a processor. The same force that liberates us from scarcity could deny us freedom. If AGI is so beneficial, or so dangerous? Why do we not have it yet? It is not a matter of effort, it is a matter of depth. Common sense, what researchers call Moravec's paradox. It is easier for AI to defeat a chess grandmaster than for a 5-year-old to understand that objects fall. Current systems lack basic physical intuition. You cannot push a rope, but no AI grasps this instinctively. Causality. Current systems are correlational. They see patterns but do not understand why. They observe cloud leads to rain, but do not comprehend atmospheric humidity. Place them in a desert with frequent clouds but no rain. Failure. Unsupervised learning. A baby learns by observing the world without labels. To teach an AI what a cup is requires thousands of labeled photographs. Deep learning depends massively on curated data, inefficient for general intelligence. Semantics versus syntax. AI manipulates symbols without understanding meaning, like someone translating Chinese mechanically without speaking the language. Operating by statistical probability, not comprehension. The physical world. Robots fail at the dexterity of a child. Many researchers believe real intelligence emerges only from embodiment, a body interacting with an environment, not merely algorithms on servers. When? Ray Kurzweil predicts AGI by 2029. He has maintained this forecast since 1999, based on exponential growth in computing power. Some expert surveys place the 50% mark somewhere in the 2040s. Rodney Brooks of MIT estimates 2,300. He argues that forecasts often underestimate the hard constraints of the physical world. Yan LeCun of Meta says we might achieve it within a decade, but only if everything goes perfectly. More likely, he suggests, we need breakthroughs we have not yet imagined. History teaches us something here. Predictions about complex systems are notoriously fragile. Nuclear fission was declared impossible hours before it happened. We would never reach the moon. We did. We would have colonies in space by 2000. We do not. Do not ignore the possibility, but do not structure civilization around a single scenario either. Prepare for multiple futures. If AGI arrives, through which door will it enter? Scaling large language models. More data, more computational power, larger architectures. GPT-2 had 1.5 billion parameters. GPT-3 had 175 billion. And in peer-reviewed research, we have already seen published trillion-parameter architectures. The hypothesis is simple. At some point, scale may transform quantity into quality. Agents and tools. AIs that use external instruments interact with the world. Systems already operate with multiple agents. One generates, another validates. Autonomous software navigates the internet, executes tasks, learns from outcomes. Embodied AI. Intelligence in robotic bodies learning through physical interaction. The thesis: embodiment may be fundamental to true intelligence. Minds that touch the world, not merely process text about it. Quantum AI. Quantum computing scales differently, but engineering reality is brutal. Optimistic estimates place useful quantum computers within 5 to 10 years. Most experts predict 20 to 30 before practical advantage emerges. No single pathway is guaranteed, but diversity suggests that if AGI is possible, it will emerge from one of these vectors, or their convergence. What is an AGI? A machine that comprehends the world, transfers knowledge, learns continuously, rewrites itself. Are we close? The real signals have not yet appeared. The bottlenecks remain, but we already have AI in an eye, artificial narrow intelligence. ChatGPT, Claude, Gemini, Grok. Extraordinary tools that are already transforming everything, already creating deep fakes, already generating disinformation. And while we debate when AGI arrives, you already delegate real decisions to systems you do not fully understand. If ANI is already changing the world, then the crucial question is not, when does AGI arrive? It is, are we prepared for increasingly powerful ANI? The machine you use today, with its real capabilities and glaring limitations, is the subject of the next episode. Because understanding what ANI truly is, what it can do, what it fundamentally cannot, clarifies why the fear of AGI is well-founded. But it also clarifies that fear sometimes blinds us to the risks already at our door. Come back. Next episode, the machine you use every day. The books and references that inform this episode are in the description. This video is part of the AI Saga, Science, Soul, and Silicon. New videos twice a week. Because at Tender Reason, we believe the question is not whether the machine will think like us, it is whether we will still be thinking when it arrives.